Hi, my name's Steve Newby. I'm the UK Threat Management Lead for Microsoft. I've been working with NHS Digital for quite a while now on deploying Windows Defender ATP across the NHS. We've spent a long time working out how this could be implemented and what it means for you in terms of how you go about managing and deploying it yourselves. I want to take some time today to walk you through some of the functionality and the portal itself, how you use it, what it means to you, and what impact it can have on your endpoints. So Windows Defender ATP is built into Windows 10 and it's cloud powered. So within that, there is nothing to deploy at the endpoints. There is an onboarding process, and the onboarding means that all of that data then feeds up into the cloud where we do analytics across that whole lot of information that's gathered. So the idea of this is it provides visibility to you as a security team, but it should be invisible to your users. They will not see any impact in terms of performance or having to learn any new functionality. Windows Defender ATP has a number of components. Now, some of these components are built directly into Windows 10. You don't have to use all of these components. You may have other antivirus solutions. You may have other security solutions that you want to carry on using, and that's fine. But taking the whole of the Windows Defender ATP suite means that you can leverage technology that's built into Windows 10 and available for use today. So things like attack surface reduction, controlling how macros work in Office, which is a real ingress point for malware and attacks getting into the environment. The next generation protection, which is Windows Defender Antivirus. The endpoint detection and response. What happens when something gets through all of the protection that you've got in place? How do you then detect that and prevent it doing further damage? And you can automate some of this as well. So a lot of you will not have the IT departments available to go through all of the alerts that you have and do analysis across that. So we can automate it and automate the response actions in a lot of cases as well. Security posture means that you can get a view across your estate as to what's enabled, what security functionality is enabled on Windows 10, and how can you improve that. So it gives you a score that you can then aim to improve by turning on and configuring various things. And then advanced hunting, the ability to look through all of that data that's gathered, to write queries, to look in real detail with a virtually instant response across everything that's coming back. So the way it works, we have a sensor, sits on Windows 10. It is also available for Windows 7 and 8.1. That is not built in, so you would have to deploy an agent. And then we have the cloud element. So all of the telemetry comes from the endpoint and goes up to the cloud, where we have machine learning, behavioral analytics to understand what is suspicious behavior that's running on that device. We can contain that and run it in sandboxes as well, so we can pull files up to the cloud, run them in sandboxes and see what is actually the result of that file running. Is it going to cause damage? And finally, the investigation and historical analysis, all of that is available to you for up to 6 months. So we collect 6 months of data on everything that's been reported in, and that can be searched upon. And as I mentioned earlier, you do not have to move all of your security solutions. If you're using Sophos or Symantec, that's fine. You can carry on using those. But just be aware that Windows Defender AV and the inbuilt Windows 10 security functionality is available for you if you'd like. So now I'm going to move into a demo. The first stage of using Windows Defender ATP is logging into the portal itself. So it's a web-based portal, and within that you have accounts that give you rights at what's called either a reporter level, which is read-only, or controller level, which is full access. So to log into the portal, you go to securitycenter.windows.com. And if I just log in with my account, which is atp.microsoft@nhs.net, it takes me into the sign-in page, and you'll see at this point it gives me my NHS banner. So it's really important that you see that when you're logging in. And if I just put my credentials in. So this has logged me in as a read-only account, a reporter account. And within that, you would then see the machines that are associated with your ODS tag. So we use the ODS tag from your trust. And when we onboard machines, they get onboarded with that ODS tag, which then puts them into a machine group. And the accounts that you have visibility over those machine groups. So you will only see the machines that are relevant to you. The other way of logging in is through a controller account. So if I just log in with a controller account, and we've got this controller account set up here. And the difference here is because of the access that you have, we've put extra restrictions on that. So if I just log in, and I sign in here. And by extra restrictions, we mean multi-factor authentication. So it's actually asking me to approve that, and it's using my mobile phone. So I'm using an app on the phone, but equally I could use a text message or a call in order to verify that multi-factor authentication. So that's me now logged on with a controller account. And within this controller account, I have full rights over everything that happens within this environment that's relative to me and my ODS tag. So I'm just going to take some time now to step through the console itself and what you view in the first page and how you then drill into each different element. So this is a security operations dashboard. This is the main page you see when you log into Defender ATP portal. And you can see we've got our active alerts here. We've got the machines that are at risk, so it orders it based upon the machines that have seen most risk. We see users at risk, and it provides the user information from the endpoint. Now I'm logged in with a SOC account, which is why I'm seeing everything, but you would only see the elements that are relevant to your ODS tag. So you wouldn't see other user information, you wouldn't see other device information. So we can see any sort of active malware alerts, the sensor health, so where you've got maybe issues around misconfigured machines, and then the machines that are reporting in. So as it stands, when we've recorded this webinar, we've got 595 machines, unique machines that reported in. So we're making good progress in terms of onboarding. And by the time you watch this, we'll probably be on a much higher number. And then we see some suspicious activities. So breaking it down by stuff that's been reported from the Windows firewall, from Exploit Guard. So Exploit Guard is part of Windows 10. That's the attack surface reduction I mentioned, and other elements such as protection against ransomware and protection against network points. So machines that are contacting suspicious network points as well. And Device Guard. Device Guard is the ability to actually lock down what's running on the device. So what applications can run. So this is my front end dashboard. Before I go into a machine itself, let's just click through some of the other things we've got here. We've got our alerts queue. So you can assign alerts to yourself, and I'll show you a bit about that. We've got our automation. And I mentioned the automation. Automation is only relevant for machines that are on Redstone 4, so build 1803. So these machines have the ability to have automation applied to them in terms of investigating the alert and remediating the alert. We've got our machine list. So when I click into that machine list, we've got the ability to filter based upon risk level, Windows platform, the health state, and the groups. So you'll see a number of groups, and these groups are what your ODS tag is used to assign that. We've got the health as a service, and we've got advanced hunting. So the ability to drill really into that data, and I'll show you some of that as well. And then we've got our settings. So as the primary user, there are a number of settings I can change on that as a controller user. If I click through, I can add notifications. So I can add a notification rule to say to me, warn me on any machines that are high alert rule. So I can show the display name. I can include a deep link, so I can click straight from the email straight into that. And I would then select my particular group. So as you know, I can see all these groups, but when you log in with your own credentials, you will only see the group that's relevant to you. So, for example, you might choose to select Blackpool Teaching Hospitals if you're the Blackpool, and it alerts severity. So I'm going to say high alert, and then I define the recipients. So the recipient here, I would have nhs.net and add recipient. So now any high alerts that come in for me that are associated with that group will then get sent directly to my email. I'll just save that notification rule. And you can see other alerts have been set up by some of the other early adopters that we've got in place here. Power BI reports, so there's dashboards that you can create within Power BI. We got secure score. Now secure score relates to the scoring of your security elements that you have turned on within your environment. And within this, you might actually choose to turn some of these components off. For instance, if you're not using Windows Defender Antivirus, you don't want it to score on your capability. So you might choose to turn it off. Other things that you're not using, you would turn off. So then your score reflects the elements that you actually have enabled. And I'll actually show you that now. So let's just flick on to secure score. And you can see here the secure score. So the elements that you've got, again, you would see elements related to your trust. And you can see here, I can click through these machines or the improvement opportunities, and I can see what I'd need to do to improve my score. So fix antivirus reporting, OS security updates. I can see which machines don't have the latest security updates on them and what I would need to do to improve that. Now within your user account rights, you won't have access to all of the settings here. Some of them are global settings that will only be changed to affect the whole tenant. So they'd be strictly for changing at the top level. However, just to explain a bit about how those settings are applied, I want to show you this. This is the roles. So we have roles defined within the security center, and these roles dictate what your account is able to do. So we've got 5 different roles here. So we've got the global administrator. That's an account that I'm actually logged in with right now, so I have rights to change everything. You have the SOC full level access. So that's the top view across everything that can be seen within the tenant. So the SOC will have access and has the ability to make some changes and perform response actions against anything within the tenant. Now that is not a role that would be normally used. By default, the SOC level will only be logging in as read-only, so they'll be able to see what's happening, but they won't be changing anything across your machines. Then at your level, you have the trustful level access, so you have rights across everything within your estate, and this is where the multi-factor authentication comes in. So you'll be able to view all your machines, you'll be able to make some changes in terms of settings, you'll be able to set up those email notifications, and you'll be able to respond. And I'll explain what we mean by respond as we go through, but it's effectively when you see an alert, what it is you're actually going to do about it. And then read only, you can have the visibility across your estate. You can see the alerts that are coming in, you can see any threats that might be happening, you can see the machines, but you can't actually do any response actions. And then we have the machine groups. So the machine groups are what we have the ODS tag assigned to. So when you onboard the machine, the ODS tag sits within your registry, and that then means that machine will automatically join into a machine group when it gets onboarded into the into the tenant. And just an example here, if we look at the Blackpool teaching hospitals, you can see here the tag, which is the RXL, that's their ODS tag, and that defines that machine membership. So you can see we've got some other settings that can be changed within that. And as I mentioned, some of them would only be for the global administrator level, the top level. But there's information around alert suppression. So when we see alerts, are we going to choose to ignore them? Stuff to look at around automation as well, where you're going to apply automation to certain files, certain folders, or exclude certain folders. And then you've got machine management, so the onboarding and offboarding. Now, for all of these components, there's additional documentation available. So in order to access the documentation, we can go here and we can go into the Windows Defender ATP guide and look at that. But there will also be specific NHS documentation around how to onboard and how to use certain other elements. So keep an eye out for that. Moving back to the main dashboard, I want to talk you through an investigation. Now, as we can see from this dashboard, we've got some alerts here, active alerts, and we've got our machines at risk. Now, depending on the way you want to approach this, you could just drill straight into the alert, or you could go into the machine. But either way, you can come to the same spot. So I'm going to go into an alert. So let's do a suspicious command, PowerShell command line. PowerShell is a route in for a lot of attacks these days. So it's what we call fileless-based attacks. So it will get in with Office macros or through other methods, and it's not a particular malware file. So antivirus, your typical signature-based antivirus, will not pick this up because it's using system tools to infiltrate the system. When we look through the alert process tree down here, we can see we've got references to what's actually happened here. So the files are involved, PowerShell being run, and we have some actions. So we can manage the alert. So I can assign that alert to myself, and I can add the comment, which will be in this case, which was a test alert. So we're actually utilizing some inbuilt simulation software that allows us to test the effectiveness of Windows Defender ATP, and I'll show you that in a minute. I can set this as a true alert, and I can determine whether it was security testing. So that's what we've done here. I could also create a suppression rule. So by creating a suppression rule, I can say, if I see this alert again, I just want to ignore it. So then we can set that. So that's now logged in the Action Center. So anyone else that logs in, again, within my own machine group, my own ODS tag, will be able to see that status assigned to that alert. So let's just go back a bit. And if we go here, and let's look at this top line. So we can see, again, we've got this backdoor.exe, and it's set a registry key. So it's actually set something to establish itself as persistent. So each part of that flags an alert condition for me. Looking down the instant graph, I can see which machine was affected. I can also see other machines that might have been infected by the same thing. Now, if I click onto the machine that was infected, you'll see I've got some other alerts associated with that machine, and I've got some actions that I can apply to that machine. So when I click the action button, it gives me a drop-down list. Now I can manage tags, so I can actually add an additional tag. So we already got the tag for the ODS, but I can also add another tag if I want to start filtering on maybe high value assets, or have a tag that's associated with a particular department within my trust. I can do that. I can collect an investigation package. So if I collect an investigation package, what that does is it pulls data for me. So I can pull that investigation package, test data, And what that does is it's now collecting that data from the machine, and it's going to pull that down and allow me to view a whole bunch of additional information about that machine. So that will come by in a bit. If we were using Windows Defender antivirus, we'd be able to initiate an antivirus scan. So this is, like I say, you do not have to use Windows Defender antivirus. It's built into Windows 10. It's regarded as an enterprise level AV solution, and the use of that enables some additional functionality in Windows Defender ATP. But if you're using Sophos, that's fine. What we won't be able to do is get data from Sophos into Defender Security Center, or initiate certain actions like running an antivirus scan. Restrict app execution. That allows us to restrict the apps so that only Microsoft signed apps can run, and that again has a dependency on Windows Defender antivirus. The final part here is isolate machine. So I can disconnect that machine completely from the network. That will cut it off from everything on the network except the Windows Defender ATP service. So I can still do some investigation, I can still look at the data, but that machine cannot connect to anything else on the network. And actually I just wanted to highlight the difference between what we see here and actually what we'll see within a read-only account. So if I just jump to the other tenant. So here we go. This is where we're logged in under a read-only account. If I click on that same machine and we go to the drop-down box, you'll see here you do not have permission to perform this action. So again, for isolate machine, you do not have permission to perform this action. So I cannot provide any response actions in relation to things that I'm seeing within the console. Going back to my main portal, I can see that machine now has collected that investigation package. So just to download that. When I download that package, what that does is it gives me data around the machine itself. So if I open that up, I can see I've got a number of different elements. What's been set to auto run, what programs are installed, any network connection I had open, prefetch files, processes that are running at the time, any scheduled tasks that have been set in. It also pulls back the security event log from that device. Services that are running, any SMB sessions that are open, system information around the device itself, what temp directories there were, and what users and groups were defined on that device. So that's available for me to look at and do further investigation if I need to do a bit more forensic analysis around what's happened on that device and the type of alert we've seen. So let's drill into the alerts a bit more. We can see here an uncommon file was created and added, and actually one of the things that's relevant about this is as soon as you click any of these alerts, it will jump to that part of the timeline where the alert occurred. So as I mentioned right at the beginning, we keep 6 months of data on every machine. So that 6 months of data allows you to drill back over that entire time and look at what's available. So looking down here, I can see the type of stuff that's been loaded up, and we can see there's a reference to Sophos here. So in all likelihood, Sophos actually flags something around that executable. But you can see the type of information that's detected. So connections with external IP addresses, processes that are starting, access tokens being modified, any sort of injection into processes. There's huge amounts of information that's collected. What we don't collect is textual content. So we won't take Word files or emails up to the cloud, so that you don't have to worry about that PII information being compromised. The only potentially PII information we do take up to the cloud is machine names, IP addresses, usernames, but again, that stays within the NHS tenant, and only the NHS would have visibility over it. Okay, so let's just go to the alert itself, and when we click on that, like I say, we can see our alert process tree, we can see the registry settings that were set, and I have the ability to click into the actual executable. So when I click into this executable, I see any alerts that are related to that machine or related to that file. I have the ability to perform certain actions against the file. So I can stop and quarantine the file. So that would allow me to kill the process. So any machine that's running that file at this moment in time, it would kill that file and quarantine it. I can then block a file. Now, blocking a file requires me to be using Windows Defender Antivirus as the primary AV solution. And what blocking a file does is it then blocks that file from running on any other machine. So any other machine that saw that file would not be able to run it. I can also do what's called a deep analysis request. So I can submit this file for deep analysis. And when we do this, it takes the file up to the sandbox and runs it in a virtual environment in the cloud to determine what that file is actually trying to do. So is it trying to contact external IPs? Is it dropping files onto the hard disk? Is it making some registry changes? So all of that will then be analyzed within the cloud. So you can see what it's done is it's just taken that to upload it. It's now running that within the sandbox to detonate it and see the results of that. So we'll come back to that in a few moments. And one of the things I mentioned earlier was the ability to do simulations on your environment. So while I'm waiting for that file to just analyze, I'll show you what I mean. So when we go to this simulations and tutorials, this takes me to a page where I can actually run different simulations to actually test what's going on with the environment. So I can get a simulation file. Now what I was showing you with the alert was this scenario 1. So this is a simulation backdoor that would be available to load into Word, and you run that simulation in Word. It's basically just a macro. That macro runs and it starts to behave as if it's malware. You've got a fileless attack where we're running a PowerShell script. So there's no malware file involved at this point. And again, that will flag up alerts. And then you've got the third scenario, which is automated response. So automated response is only available if you're using Redstone 4. So build 1803 of Windows 10. And this is where we're looking at the response capabilities for our automated incident response. This allows us to take that alert, pull all the relevant information together, and automatically respond to it if we need to. So those 3 scenarios are available for you to test, and I would encourage you to run through some of those. When you onboard a device, run through those scenarios. You can see you've got the files and you've also got the walkthroughs. The walkthroughs explain exactly what you need to do in order to test that. And that's a great way of proving that the solution's working in your environment. So we've now had a response to that. In terms of the deep analysis, we've had the results returned. And if we just open this, we can see it's actually, as it's not a true bit of malware, it's not doing anything really malicious that's being picked up on. So we can flag stuff like it's connecting with an external IP address, it's checking some assembly log values. That's about it, because it's not particularly malicious. But other files, other malicious files, you will see huge amounts of data. Even certain other legitimate files, you can send any file you want up for detonation, any executable file, I should say, and you would get the results of what that file is trying to do. So to come back to the main dashboard, there are a couple more things I wanted to show you before we finish up. Actually, one of the interesting things is that since I've been recording this webinar, the number of machines has actually gone up. So we started off at 595 and we're now at 608. So one of the things I wanted to show you was the automated investigations. Now, I talked about this at the beginning. It's one of the new bits of functionality, and it's available for machines that are running RS4 or build 1803 of Windows 10. Now, if we go into the automated investigations, we can go in directly from this dashboard, or we can click on this button here. So clicking on that, that takes us into the automated investigations page. And I see, again, I've got the ability to filter. So I can filter based upon machine groups, machines, any comments, the type of alert that was used as part of the trigger event. So all of this information is pulled together for me. And that's one of the real benefits of this automated incident response. So we can see here the automated investigations that have surfaced. Now, these are against a single machine. There's been some tests run against this machine, and this is build 1803 or RS4. So if we click through these, it gives you visibility about what that automated response is doing for you. If I click on this, then it gives me an expanded view. It tells me which machines are infected, where did the alert come from, what entities are analyzed. So as part of this, it actually performs some actions on the endpoint to do further analysis of that endpoint. So it allows us to isolate files. It allows us to kill services or processes. We can isolate registry keys as well as part of the automation. Now, the automation is something you would set up in terms of whether you want it semi-automated or fully automated. Our advice is that you would start in a semi-automated mode, and then it presents all of this data to you, and at which point you'll get an alert presented to you, and then you can choose to decide what you want to do. It'll give you a recommended action, and then you just action that, so it will come under pending. With the fully automated, it will just do it for you. So you may find that you choose to start with semi-automated, and then as you become more confident in a solution, you move to a fully automated environment. And that's something that you can select as part of your own policy that then gets applied. As we come to the end of our webinar, I just wanted to recap on a few things. So this is the main dashboard. I can look at my users, I can look at my machines at risk, look at my sensors at health. I have the ability at this level to just do a basic search. So I can search for file names, IP addresses, URLs, machines, users, and that will search through my potentially 6 months of data. I also showed you the secure score dashboard. So the idea is to get your score as high as possible, and that's what you're aiming for. You won't get to that optimum score, but you want to get that as high as possible. And it gives you the improvement opportunities, and it also gives you your secure score over time. So you'll see what different elements are turned on. This is just flagging EDR, but I can also select here total score, and I can see what the total score is and the individual elements as well. There is one final dashboard I haven't shown you, and that's the threat analytics. So threat analytics looks at the data that's coming in and provides information related to some of the big threats that we've seen in the industry today. The most recent big threat was the Spectrum meltdown. So we've given you information in this board around what state your machines are in. So looking at all of the machines of the 464 machines that we've done the analysis on, the operating system mitigation, so the patch is in place, but the microcode mitigation isn't. So the hardware patch isn't in place. So it gives you that quick view. And actually, we've just seen a pop-up from the automation. So that's quite timely. We can look straight into that. And we can look at the remediation actions. And if I look here, so it's saying we're requiring user approval to quarantine. And at which point I can choose to quarantine that file if I so wish, or reject it. And that's related to that backdoor.exe. And this has been done as part of the automated investigation. So it's run on that system, and it's presented me with the option to approve or reject that. So we've reached the end of our webinar. Thank you very much for your time. As I said, there's huge amounts of information out there. That information will be the information that's available on the Microsoft website under Windows Defender ATP, and obviously also available through that portal, through the help function within the portal. There's also documentation that's being written in conjunction with Microsoft and NHS Digital around specifically how you onboard and how you manage your systems. So keep an eye out for that, and keep an eye out for further webinars. Thank you. Goodbye.